Hi friends, we are going to see the next problem in the graph algorithm of CSES message route. So we are given n computer and m connections, and we need to find out if we can send a message from the connection 1 to connection n if we have this m connection over there, and if yes, what is the minimum number of computer on such a route. And I think we also need to print the path from where we can go there. So the first input would be n comma m. There are five computer and five connection 1 2 1 3 1 4 2 3 5 4. So in this case we can go from 1 to 5 via 1, 4 and 5 because 1 is connected with 4 and 4 is connected with 5, and this would be the minimum uh, minimum length that we can go from. So this is the problem of BFS, where we need to find the minimum path, and the tricky part over here is finding the actual path from where we can go there. So for that, what we can do while doing the BFS, we can keep track of the parent node of every node. And what does this parent node indicate? Parent node would be the first node which discovers the current node. Let's say 2 is connected to 3 and 4 is also connected to 3. But while doing the BFS, we first came across 2 and then 2 discovers the 3. So the parent of 3 would be 2 and 4 also discovers 3. So its parent would not be 4. The 3's parent would not be 4 because the first discovery was done by 2. So let's start by writing the code. So we have n comma m. We'll create our adjacency list after of and it would be of size n, and we'll take input for m times, and as this is one index we need to decrement this because our adjacency list is of size n only and starts from 0 index. This is a bidirectional graph, so we'll push in both of them. Our source is 0 and our destination is n minus 1. So, and for doing BFS, we need a queue also. So let's initialize it. Let's give the name queue only and initialize it with the source node. And now we will have the basic approach of BFS, where we apply the while loop, while queue dot size. We will remove the first node from here. Let's give the name as safe. We can find it using front, and then we can do queue dot And now we will discover its adjacent nodes. So for auto I of adjacent of front, we will push it into the queue if it is not visited. So we will need a visited vector also over here. And when we push it, we mark it as visited. So for 0 also, we will mark it as visited. And remember for BFS, we mark this as visited once we discover it. And we also need a parent vector also. And let's initialize all parent equal to -1. So zero's parent would also be -1. And whenever we discover something, we'll mark it parent, its parent. Parent of I would be equal to the F node from which it is discovered. Now we can check if we have visited destination, then we can do something else we need to print impossible. And in this case, we need to print the length of the path. Like in this case, it is 3, that is 145. So first we can construct the path. So let's say vector of int path, and we can apply a while loop over here. While parent of destination not equal to -1, then we can push it in the path. And we can change the destination. So initially our destination would be n-1. So n-1 would be pulled here, then we will go to its parent until it would become parent of 0. So parent of 0 would be -1 over there. So now we have got our vector, we need to reverse it. And after reversing, we need to first print the size of this path. And then we need to print the whole path with the space over there. So let's try to compile this code now. And let's try to run our input. So the path length should be the same, and we can print different paths. Any of them would be accepted. So there are few mistakes over here. First of all, we need to print I plus 1 because we have converted it to 0 indexed earlier. So now we have to convert it back. And also, when the parent of destination is not equal to minus 1, it will also cover the case of when the destination is 0. So our path is never pushed back with 0 over here. But in this case, we are sure that the destination would be reached. So we can directly push our path over here. Path dot push back 0. That is our source. And we have reversed it and we have incremented it so that it would be one index only. So now we are getting the right answer. Let's try to submit this solution. So as we can see, our solution is accepted. Thank you for watching. See you in the next video.